In this video, we're going to be practicing solving a right triangle. Solving a right triangle means find all of your unknown measures, so all of the missing angle measurements and all of the unknown side lengths. You got to solve for all the missing pieces. And when we do that, we're going to use a combination of our trig ratios or inverse trig ratios. Let's try and remember all of our techniques to solve a right triangle. If you know one side length and one angle measure, you can use trig ratios to find the other side lengths. If you know at least two side lengths, you can always use the Pythagorean theorem to find that third side length. And you can also use inverse trig functions to find angle measures, but you got to know at least two side lengths to do either of those things. If you know one of your complementary angles, since we already have that 90-degree angle inside a right triangle, if you know one of your other complementary angles, you can just use subtraction to say 90 minus the angle that you know. So let's practice all of those methods and try and solve some of these right triangles here. So in these two examples, we know a side length and an angle measure. So we're going to use trig ratios to solve for our other side lengths. And we could just use the definition of complementary angles to solve for our other angle. Let's do that first. Angle A is going to be whatever 90 minus 62 is. So that's 28 degrees. And now that we know both angle measures, to help us solve for our side lengths, that gives us a lot more possible trig ratios to use. However, be careful if you're using a value that you solved for, because if you solved for it incorrectly and now you're using that value, it's not going to help. So most times it's always better just to use the values that are given to solve for all of your missing pieces. That way you don't make mistakes. So based on the information given, I'm going to solve for side length A. I can use the opposite side length and the adjacent side and this angle, and I can use the tangent ratio to do it. So the tangent of 62 degrees is equal to my opposite side over my adjacent side, or 8 over A, and then we can cross multiply and solve that proportion to find our side length A. Oh, one thing I forgot to mention, but maybe you already saw the picture up here. In general, the most generic way to label a right triangle is to use capital letters for the angle measurements. C is generally used for the right angle. A and B may switch spots. Across from those capital letters or angles is going to be the side lengths with lowercase corresponding letters. So across from angle capital B is side length lowercase b. Across from capital angle C is lowercase side length c. And across from capital angle A is side length lowercase a. All right, back to this example. Solving for side length C now. Just using the information given, I can use my opposite side to solve for my hypotenuse. As long as I have an angle, I can use the sine of that angle. So the sine of 62 degrees is equal to the opposite side over the hypotenuse, or 8 over c. Anytime you're missing the lower part of your ratio, you're going to divide by your trig value. So 8 divided by the sine of 62 gives us about 9.1. So there we go. We solved for all the missing pieces in that example. We could work on this next one. So we're given an angle, we're given a side length. I'm going to use that information to solve for side length B and side length A. Again, to solve for angle B, we could just use definition of complementary angles. I know that these two angles are going to add up to 90, so 90 minus 59 is angle B, or 31 degrees. To solve for side length A, since that's the opposite side from my angle and I have my hypotenuse, I'm going to go ahead and use the sine ratio. Sine of 59 degrees is opposite over hypotenuse, or A over 9. Cross multiply to solve, and we get about 7.7. To solve for side length B, that's the adjacent side to my angle. So if I have the adjacent side and the hypotenuse, I'm going to use the cosine ratio. So the cosine of 59 degrees is equal to the adjacent side over the hypotenuse, or B over 9. And again, cross multiply and we can solve it, and we get about 4.6. All right, what if we have examples where we know two side lengths? How can we solve for the missing pieces? Well, to solve for the third side length in a right triangle, if we already know two of them, we can always use the Pythagorean theorem. So to solve for side length C, I can say a squared plus b squared equals c squared, or 14 squared plus 16 squared equals c squared. Square root both sides to solve for c. Simplify this, and we get about 21.3. If I want to solve for an angle measurement and I know two sides, I'm going to use an inverse trig ratio. So to solve for angle A, if I use the opposite and adjacent sides, I'm going to use the inverse of tangent to do that. So the inverse tangent of opposite over adjacent, or 16 over 14, gives me about 48.8 degrees. To solve for angle B, we could use the definition of complementary angles, 90 minus angle A, or we could verify that by using the trig ratio. So this time, if we're hanging out at angle B, the opposite side is 14 and the adjacent side is 16. So if we use our inverse tangent of 14 over 16, then we get the angle measurement for angle B. And then we can verify and make sure they add up to 90 degrees. All this other stuff is just additional methods that we could use based on pieces that we've solved for. And again, be careful. You have to be confident that you solved for a piece correctly before you start using it. Over to this last example here. I know two side lengths. I'm going to solve for side length A. I could use Pythagorean theorem. Once I know an angle measurement, I could start to use trig ratios. I'm going to go ahead and use Pythagorean theorem first. So a squared plus b squared equals c squared, or a squared plus 5 squared equals 15 squared. If I subtract 5 squared from both sides and square root, I can start at this step. Simplify all of that, and we get about 14.1. To solve for angle A, using the information given, I have the adjacent side and the hypotenuse side. So I'm going to use my cosine ratio. But in order to solve for the angle, I need to use the inverse cosine ratio. Adjacent over hypotenuse, or 5 over 15. Plug it into your calculator, and it should give you about 70.5 degrees. Again, use the definition of complementary angles, 90 minus that to get angle B. Or we could use the information given. If we're sitting over here at angle B, we have the opposite and hypotenuse sides. So I could use the inverse of sine and 5 over 15 into my ratio, and I should get about 19.5 degrees. Again, double check and make sure you have complementary angles here that add up to 90. So lots of different ways to solve a right triangle. But solving a right triangle essentially means find all of your unknown measures.